Good morning, everyone. Just making a quick video to give you some instructions on what I want you to be working on today. Just remind you once again that I will be missing for those first few minutes of the class. I am going to be opening up the Google Meet so that you can get online together and ask questions of one another. And that way, when I come back, it will be on in the classroom. And when I come back, I can just jump in and check in and see how things are going. Now, if you have internet that's kind of spotty and you find that it's not easy to be on a Google Meet and do other things online, feel free to jump out of the Google Meet for a while and try and work on the other things once you understand what I'm wanting you to do. But please, about 25 after 9 or so, make sure that you're back into the Google Meet so that when I come back in the classroom, we can wrap things up and talk about things together. Okay, so in Google Classroom, please go to Classwork. You're going to see that there's an entry there for Wednesday, May the 19th. And in there is a document called Transformations of Graphs Lab. So once you open that, use that link, it will lead you to the following document. Sorry, I should have had scrolled to the top. There you are. So with this one, what I would ask before you do anything with this document is that you make a copy, please. So use the command over at the side to make a copy, creating a copy that you're free to work on. I found, because I need you to have access to some links that are in this document, that PDFs wouldn't work. And if I gave this to you, that there was a chance that you were going to be writing on the original if you started in on it. So that's why I'm asking you, please, to make a copy. Once you've made your copy, you're free to move around and begin to enter things in as you need to. So first of all, the first instruction is to use the Desmos application on your Chromebooks to match the following graphs with their functions. Some of these graphs that I've given you, you know, and others are new to you. So for example, in the first one, I'm asking you to match y is equal to x squared with the graph below that it looks like. Now you know this one, but just to kind of demonstrate what it is, you're going to go to Desmos, put in y is equal to x squared. Once you see what the function looks like in its original form, go back to your copy, look for where I've put it. You can see it's letter H, and so you can simply type in H. Okay, and you can do that for the rest of them as well. So these are important graphs. These are graphs that are key to what you do algebraically in mathematics in the upper classes. So these are really important graphs to recognize and to be able to know what they are in terms of their equations and what they look like. So the second thing I want you to do is to play around with these. We call them parent functions. These are where the functions begin. And I want you to play around with them to see what happens when you start to add numbers in the front or numbers inside with the x's or numbers on the end. Now, what I've done is I've created graphs for you to work on. So this you'll find is a link, a hyperlink to take you to a slider graph, something that you can play with. So this one will take you to this guy. And it gives you the ability to play around with these guys. So if you watch, let's start with the a value, the one that's out in front of the function itself. When it gets to be a larger number, my graph is getting steeper. When it goes back to where it started, which is a good thing to remember where it started at 1. Hang on. Oh, there. There. And then when it goes under a 1, as you know, it gets wider until it gets to 0 when it's completely flat. And then it flips over the graph and starts to do the same thing in the reflection. So I want you to take note of that and make notes of that on your graph. So on your paper, you'll go back and you say, when a is greater than 1, the graph gets steeper. When a is a fraction, the graph gets flatter, wider. When a is less than 0, the graph reflects. in the x-axis. Now I can see that the formatting for this, because I did put some things in there, is kind of extra. So as you go through this, you might want to just erase that part so it's not too big as you work on it. Okay, let's take a look at the next part. So I'm going to put my slider back to +1, which is where it started. Yep, there. And now I'm going to mess around with a b. So when b is a positive number, it moves my graph to the right. When b is a negative number, it moves it to the left. So then I move it back to 0, and I write in my copy of the transformation. When b is positive, or you could write greater than 0, the graph moves to the right. When b is negative, less than 0, the graph moves to the left. Okay. And then once more, you go back and you play around with the c values and play around. When it's positive, it's moving up, and when it's negative, it's moving down. And put it back at a 0. Oh, wait, I've got to find a 0. Yabba dabba do. There we go. Okay, and then I go back into my copy of it and I write my notes. When c is positive, the graph moves up. When c is negative, the graph moves down. Ready? So there you go. And you're going to be doing the same thing for each one of these guys, playing around with them, checking to see what happens as you move through these. You'll also find at the very end that I ask you to summarize what you're seeing in these so that you can begin to get a sense of what happens with these various values that we place in front of graphs. Okay, so that's your assignment for today's class, and we'll talk about things together once I get back. Okay, take care, guys.